Hi, ladies, it's Mr. O'Sullivan. It is April 9th. This is an edPuzzle lesson, so it is Friday, finally Friday. So today we are going to go over how to graph the exponential function. This is the newest function we learned about this unit. And today's learning target is I can graph an exponential function by using my calculator or Desmos or Calculate 84. So I've gone over in previous videos how to use Desmos, but for this lesson, I'm actually going to focus on using Calculate 84. The reason why Ms. Townsend and I are going to focus on Calculate 84, this app that you see on my screen, is because it actually mirrors exactly what the calculator we use in our school looks like, okay? So by definition, an exponential function is a function in which the variable is an exponent. So I'm going to be putting my x in as an exponent. So here are some examples of exponential functions. My first one is y equals 5 to the x. And the reason why this is exponential is because, look, my x is an exponent. My next example that I created is y equals 3 times 1/2 to the x. That's also an example because if we look, I have an exponent. That's an x. And then my next example is y equals 2 to the x plus 1. So please pay very close attention to the language we're using and all of that fun stuff. So graphs of exponential functions, here's how you're going to be graphing them. Here's your procedure. You're going to be making a table of values using your calculator, and then you're just going to graph them. We do not need to go through this whole process. I am not going through that whole process for this lesson. There's no need to because I'm going to just be showing you how to do this on a calculator because it's much quicker. So what we're going to be doing right now is we're going to be graphing y equals 3 to the x. We're going to be graphing it right here, and this is the function we're graphing. All you're doing with these x values is plugging them in for x. So I'm going to show you, if you want to do this by hand, this is how we would do it, but takes a while. So basically everywhere you see an x, you're just going to plug in these numbers. So I'm going to do y equals 3 to the negative 2. I'm also going to do y equals 3 to the negative 1, y equals 3 to the 0, y equals 3 to the first, y equals 3 squared, and y equals 3 to the third. Now, the thing is that doesn't really tell us much because I'm not going to be like, oh, Lachey, can you go plot y equals 3 to the third? No, that's pretty weird. We need to know what that number is. So what we're actually going to do is we're going to go to our Calculate 84 app. We're going to go to y equals. I'm going to hit clear. And what we're going to do is we're actually going to type in 3, and then we're going to raise it to the x power. Now what I'm going to do is I'm going to hit second, graph, and if you look, I get these. So if you look, when I type in negative 3, I get this on my screen right here. I get that 0.37, 0.037, 037, 037, 037, 035. That actually ends up converting to 1 over 27. So my y value is 1 over 27. So when I plot this, I'd be plotting negative 3, 1 over 27, because it goes x comma y. Now, when I type in 3 to the negative 2, I get 0.1111. I don't know what that is as a decimal. As a fraction. So I'm going to go back to my main screen and type in 3 to the negative 2. I'm going to hit enter, and I get that exact same thing, but I really want the fraction. So I'm going to hit math, enter, enter, and I get 1 over 9. And it converts it to a fraction for me. So I would be plotting negative 2, 1 over 9. Now I'm going to type in 3 to the negative 1 because that was also a decimal. I get 0.33 repeating, so I'm going to hit math, enter, enter, and I get 1/3. So I'm going to be plotting negative 1, 1/3. Now, if you remember, I'm going to go back to my table of values, and then I get my nice numbers. So when I plug in 0 for x, I get 1. So I'll be plotting 0, comma 1. When I plug in 1 for x, I get a 3. So I'm plotting 1, comma 3. When I plug in a 2 for x, I get a 9. So I get 2, comma 9. And when I plug in a 3 for x, I get 27. Now what we're going to do is we're going to plot those values. Here's the issue. It is going to be very, very challenging to plot these values right here because of those fractions. So I'm going to tell you, hold off on plotting those. Hold off. So we're going to plot our 0, 1 first, our 1, 3, our 2, 9, and our 3, 27. So I'm going to go out to 0 and up 1. So I'm going to plot a point right here. I'm going to plot a point at 1, 3. So I go out 1, up 3. So right there. Now I'm going to go out 2, up 9. So right over here. And I can't plot 327 because it doesn't happen on my 10 by 10 grid. It's going to be like somewhere over here or something. But if you look, what I'm going to do is I'm actually going to go back to my y equals, and instead of hitting second graph, I'm going to hit graph. If you look, my graph looks like it's touching 0. However, it's never going to touch 0, and here's why. I'm going to hit second graph, and if you look, I never hit 0. I just get very close to 0. So what we're going to do is we're going to make sure that our graph doesn't touch 0. So I'm going to draw a line going up like this. And then I'm going to make it slowly approach my x-axis as good as I can. And that is what our graph of y equals 3 to the x looks like. It will never touch your x-axis. So the graph of y equals 3 to the x is an example of exponential growth. And the reasoning why is because your graph is increasing for all values of x. And the value raised to your exponent, so like the value that's attached to your exponent, so in this case, your 3 will be bigger than 1. So here's something that I didn't get to write at the beginning of the video, I forgot to, is that your general form of an exponential function is going to look like this. That's your general form of an exponential. Your a is your initial amount. And your b is your multiplier. So if I look, the 3 is my multiplier. Your initial amount occurs when x is equal to 0. So in this graph, my initial amount is 1, because when I plug in 0 for x, I get a 1. So the value raised to your exponent will be bigger than 1. So when we write that, if we want to use the math language, we can say b is going to be greater than 1. And if we look, we know that's true, because if you look, 3 is greater than 1. Okay. Let's go on to our next example, where we look at something with a fraction now. In this example, we have y equals 1/3 to the x, and that 1/3 is in parentheses. So we need to make sure that whenever we make a substitution, we put that 1/3 in parentheses. So what I'm going to do is I'm actually going to do y equals, I'm going to clear it, parenthesis, alpha, y equal, enter, and that makes a fraction. And now I have my 1/3. I'm going to close my parenthesis, and now I'm going to raise that 1/3 using this caret symbol to the x. Now I'm going to hit second graph, and I want to plug in -3, -2, -1, 0, 1, 2, 3. So what I'm going to do right away is I'm just going to make that substitution. So I'm going to do 1/3 to the -3, 1/3 to the -2, 1/3 to the -1, 1/3 to the 0, 1/3 to the first, 1/3 squared, and then 1/3 cubed. So now when I look at these numbers on my handy-dandy calculator, when I plug in -3, I get 27. I get 27. So what I'm going to be plotting is -3, 27. When I plug in -2, I get 9, so I'm going to be plotting -2, 9. When I plug in -1, I get 3, so I'm going to be plotting -1, 3. So if you look at this, your y values are decreasing. When I plug in 0, I get 1 again. And then I get my decimal. So we get that 0.33. So if I remember, I can just go back to my main screen by hitting second mode. And now I'm going to do 1 divided by 3. Or if you wanted to, you can just do your alpha y equal. So I'm going to do my parenthesis and do alpha y equal enter. Type in my 1, type in my 3, close the parenthesis, and now I'm going to raise it to the first power. When I raise it to the first power, I do math enter, enter, because I get that decimal, and I get 1/3 again. So what I'm going to be plotting is 1 1/3. When I plug in my 2, I also got a decimal again, so I'm going to do alpha y equal enter, 1/3, and now I'm going to square it. I'm going to hit enter. I get 0.1111, hit enter, enter, and I get 1/9. And then when I do 1/3 cubed, I do the exact same procedure. Parenthesis, alpha y equal enter, 1/3, close your parenthesis and raise it to the third. And then I get 0.037037 or whatever. Math enter, enter, and I get 1/27. And what we're going to do is we're going to do the exact same thing we did before. We're going to only plot those nice points. So I'm going to attempt to plot the -327, but if you look, when I go to -3, there is no spot to do my 27, so I'm not going to plot that. I will plot, though, my -29. So I'm going to go out 2, up 9. I'm now going to plot my -1/3, my 0, 1, and then I can't plot 1 1/3, I can't plot 2 1/9, I can't plot 3 1/27. But if you look, my values are getting close to 0, but they're not going to hit 0. So when I draw my graph, I'm going to come very close to my x-axis. And look at how slow I'm moving. And if we hit graph, that's exactly what's happening. It's coming very close. It looks like it's touching. Again, this is a computer, but if you look at your y values. I'm never hitting 0. I'm just getting very close to 0. Never hitting it. I'm getting very close. It's sort of like Dogecoin. So now when I look at this, I need to ask myself, is this an example of growth or decay? Well, this is easily an example of decay. This is decay because if you look, your graph is going down. It's going down. So this is decay. So this is an example of exponential decay because your graph is decreasing for all values of x. And then the value raised to your exponent will be smaller than 1. So if you look, my 1/3 is smaller than 1. And I can verify that by just doing 1 divided by 3, hit enter, and I get 0.333, which is smaller than 1. So asymptotes. This is a word that you're going to be seeing a lot in Algebra 2, so I want to expose it to you right now. It's actually a very important word because it means a lot of important things, and it plays a very big role, especially when you get to calculus in terms of limits. And it's a line that the graph approaches but never touches or crosses. So it's basically sort of like when you look at this, I'm coming very close to it, but I'm not touching this axis. So in the above graphs, the equation of your asymptote would be y equals 0 because we are not crossing y equals 0 ever. Now, if we look at our table of values, I'm going to hit second graph. I'm never going to hit 0. Never going to hit 0. If we look, this e -12 means that I'm going to have like 12 zeros before this 3. So I'm coming very close, but I'm never going to touch. So no, you will never hit 0. But you will come close. And now for a summary of today's lesson, here's our basic exponential equation. Remember, our basic exponential equation is y equals a times b to the x. I'm just going to take a quick screenshot of this. So our basic exponential is y equals like your beginning value times your multiplier raised to the x power. So if you think about it, your beginning value is your A value and your multiplier is B. And then you have your X, that's being your exponent. So your initial amount is your beginning value, and that is when X is equal to 0. So to find out your initial value or your beginning value, you just plug in 0 for X. And when you do that, you end up getting an ordered pair, and your ordered pair will look something like this: 0, comma, B. And that's your beginning value. And that's it. So next week, you're going to be having a quiz, I believe on Tuesday, that's covering, is it linear, is it exponential? And then graphing an exponential function, right? If you have any questions, please email myself or Ms. Townsend. There is no Delta Math or Desmos. It is just this edPuzzle. So be prepared. On Monday, you're going to have a quiz review, and on Tuesday, you're going to have a quiz. All right? Again, if you have any questions, email one of us. Have a great day, ladies.